Thank you so much for joining. So in this video, I continue exploring Service Bus. So we are going to see how to read messages from the Service Bus. So in order to do that, I'm going to use .NET Console application for simplicity. So we will use how to connect to Service Bus programmatically to send the messages first. Then programmatically, we pick the messages from the Service Bus topic. And I'm going to use the console application for simplification of the code. Later, I'll explain the same using Azure functions. If you understand my pattern, I'm moving towards microservice pattern. So later at some stage, I will create a complete microservice architecture flow with different layers and show it. But in this video, we are going to explore the service bus, how to send messages, read messages. So the reading of messages, we call it as a peak messages. We will explore. Hope you like this video. So the namespace we need to install to access the code from C#, it's Azure Messaging Service Bus. You can see the snapshot of the package. So you have to install the package in your project in order to access the classes and other namespaces, which will enable your code to read and write messages to Service Bus. So I created a new console application and named it as ServiceBusProcessor. So let's install the required package, which is nothing but to the browse Azure Messaging Service Bus, select it and install it. Yes, our console application is ready to interact with the Service Bus message. Let's see what I created. So I created a .NET Updates Service Bus demo Service Bus namespace. And for that, I created a topic called .NET Update topic. And this topic has two subscriptions. So the .NET Update subscriber and subscriber 2. I set up a simple console application and I added the main method and program.cs. So like these are the parameters I defined, connection string, a connection string to the service bus namespace. I'll show how to retrieve the connection string from the Azure and put it here, and the topic name. So these three classes, so this client class will able to connect to your service bus. So when you instantiate this client, it will create a connection to your service bus. And the sender, when you instantiate this, will pass the topic name and the subscription and also the client object. And then processor. So this will enable you to process the messages. So let's initialize all these parameters. So let's see first how to grab this connection string. Go to your Azure portal, go to the service bus namespace, and left side settings, shared access policies. So there is one access policy I created. So this is the default access policy. If you want, you can create multiple access policies for multiple applications, or you can use the same. So their primary connection string, either you can use primary or secondary connection string. So I'm copying this primary connection string, go to your console application and put it here. So again, I'm hard coding here for simplify the code, but you can keep it in the configurations. Then this is the name of the topic which you are trying to connect. So like under topics, you can have the topic. So this just copy this and put it in your topic names. Okay, so then first I instantiated the ServiceBusClient class. So when I'm instantiating the class, I'm passing the connection string as a parameter. So this will create a connection to your service bus namespace. Then sender. So client dot create a sender and the topic name. So the client object we are creating for the service bus namespace, but the sender is for the topic. You can have multiple topics or queues in your service bus, but we are sending a message to a specific topic. So the creator sender of the client object, method of the client object, by taking a topic name, it will create a connection to the sender. Since the ServiceBusClient and ServiceBusSender, they are expensive resources. So I kept them in the try, catch, and finally block. So in the try block, I am instantiating, and in the finally block, I'm disposing. So that I'm not creating any memory leaks. And I also created a method called send message to topic asynchronously. So here I'm creating the message body. So you can create a wide variety of types, like you can send a JSON, XML, or any kind, but I'm using a simple string. So .NET update sending message at so and so date time. And then I am creating a service bus message object, because the service bus message takes the message in this format. So I'm creating service bus message object. I'm passing the message string. So finally, I'm calling sender. So this sender is nothing but the sender I created here for this topic. So sender dot send message asynchronously. So this will send the message. Fire and forget. So once this successfully executed, if there is any exceptions, that means our message is not sent. If there is no exception, means we can rely and reliable, and the message has been sent to your service bus topic. Let's run our code and see. Running the code. The breakpoint at the end of the thread. Still running very first time. So now created sending. So this method, it's preparing the message and it's preparing the service bus message object, then sending the message. So let's go to the Service Bus Explorer. So we have two subscriptions, and you can see subscription under .NET updates and subscriber 2, the message has been sent. Means you're sending message to one topic, and the number of copies will be created, like how many number of subscribers you have. If you have 10 subscribers, 10 each copies will be created and delivered to those 10 subscribers. And you can read the message here. Message enqueued, time of the enqueue time, the delivery count 0, state active, the size, and the text. .NET updates sending message at 1 to 2006 7:53:34 p.m. So now let's create processor. That means process which is reading this. So here I declared a service bus processor object, and here I'm creating the object. So how can you create a service bus processor object? Client dot create processor. You need to send the topic name, the subscriber name, and service bus process options. So we can see the service bus process options later, but here when you are creating object of the sender, you are sending, you are only passing topic name, But when you are instantiating the processor, you're passing the subscriber name, because this particular processor is going to point to a subscriber mentioned here, and it's going to read messages from there. So if you have 100 subscribers and you are creating only processor for one subscriber, this processor will read only messages for that particular subscriber. All the remaining 99 subscribers will have a message until somebody reads it. Since I need to read the messages when there was a new message arrived, so it's a kind of event-driven mechanism. So like when somebody submit a message to my service bus topic, my application need to um, read the message. That means my application, the reader need to listen to this service bus topic. So when there is a message, it can read it. So in that case, I need to instantiate the processor a little different using the event-driven mechanism. I'm going to do that. So here I created a message handler by passing the message process message event args. So so this args will contain the all the details like which service bus namespace and which topic and which subscriber, and then it's going to pick the first message, the top message, and once this get picked, so it will mark the message complete. That means it will the message will move out from the topic. I'll show this. And also I defined error handler. So error occurred, any error messages I'm going to display, and I'm making this task completed. So since it is a event-driven mechanism, I'm going to use, since it is event-driven mechanism, I'm going to use the delegates. So this processor, so add handler. So processor dot process message asynchronously. So this is not a method, it's an event. So it's a delegate actually. Process message asynchronously is a delegate. So this delegate will take message handler as the address. So when you are doing the process message asynchronously, you have to create the error also. Error handler. So processor dot process error asynchronously. Process error. Yeah, error asynchronously. These are equal to error handler. Error event handler. That error event handler or error handler. Error handler. So if you want to know about delegates and handlers, so in my YouTube channel, I created a video like how to create what is delegates, what is handler and delegates, how to instantiate the delegates in different ways. So please go back to the channel and find the video. And if you need any information, let me know. I'll provide. We are not yet done with the process instantiate. So we need to start the process. Because it has to listen and always run. So in await processor dot start asynchronously. Two methods, start and stop. So first I'm going to start it asynchronously. I'm going to add few more statements like this will hold the application. Otherwise the application will exit. So if you want to process messages continuously, you have to hold it. So this statement, it will hold the messages. And then once if you want to stop the process, so you can say stop process asynchronously. And let's run this and keep debug pointer so that you can understand. So now this console application is equipped with sending messages as well as processing messages. So let's run this and already we have one message, and when I run this code, one more message will be sent. So first it's sending the message, run it. This will send the message. You can go back here and refresh your subscriptions. Go to the Service Explorer and see there was a message already. And now you have two messages. And but your application is running. So since there was a message, the message handler have been hit, and this message handler will be executed n number of times, where n is equal to the number of messages. So I have two messages, so now it's going to execute one. So already it's processed one message, and you can see .NET updates. So they received .NET update sending message at 1/2/2016. So this is the first message. Since the message one already processed, you can see only one more message. But if you go and see the other subscriber, you will see the two messages because nobody is processing the messages for subscriber 2. So once I complete the execution, so it's going to process one more message. So you can refresh. The moment it completed, it will move out from the queue, and you can see sending message at 1/1/2006. The timestamp option 1. Let's remove the debug pointers and see. So when you run this code, so the message will send, still sending. So yeah, the message got sent, and even the message got processed. Will this process only process the message from the console application? Let's add few messages and see. This message been added manually. So let's send this message from the UI and see here. This message has been added manually. So that means if you are sending messages from any source, so this is going to read. Again, sent message. I'm not sending. You can see the console. So only we have the last message we received is the message has been added. Now I'm sending again sent message. Just send it, and you will see the console updated with the again sent message. See, again sent message from subscription. So successfully we finished how to connect a console application to your service bus and send messages programmatically. And then we have seen how to peek the messages by using the same console application. So during that process, we have seen how to instantiate the sender, receiver, and the service bus client itself. The sender can be asynchronous, but the receiver, it need to listen. So it's a event driven. So when you define the event and when there is a new message to the service bus topic, the event will pick the message and process it. And we have seen the required namespaces and the classes, how to instantiate the client, the sender, receiver, and then how to even dispose the object. So because this service bus, all Azure resources are expensive. So when you are dealing with service bus topic, you have to dispose all the objects explicitly. Otherwise, if there is any exception and if you don't dispose it, or if you don't handle it, they're going to create a memory leak. Thanks again for watching the video. Please share your feedback. Also suggest your interesting topics on Azure. I'm going to definitely take that input and prepare the video on priority. So I hope you're enjoying the topics and they're making some usefulness. So sit tight and watch for next videos. Thanks again. Happy coding.